Mr. Hellman with 7th grade science, and today we are learning about rotations and revolutions. Now before we begin, you have to understand a couple of the things that we're looking at. This is obviously a globe, the Earth. This represents what we live on. And I don't have a good representation of the moon, so this little miniature basketball is going to be the moon today. It's not the exact same proportional size, but it will do. And then we also need a sun. Now the sun is usually very hot and very bright, but instead we have someone representing the sun, which is Mrs. Wilson, who is neither hot nor bright, but she'll have to do. So, Mrs. Wilson, if you would, turn on the sun for us there, please. All right, you can see it hitting through here, and then this is going to help us to understand the differences between the seasons, the rotations, the revolutions, everything that we use today. So, first of all, we're in the middle of summer right now, and so what we look at is, at this point, most of the sun's rays are going above the equator right here. So as it goes above the equator, it's just right about here, the direct sunlight. But then as the world continues to revolve around the sun, notice I'm spinning it pretty fast because there's going to have to be well over 90 some rotations before it gets to over here. And then at this point, the sun's direct rays are now hitting over the top of the equator. And this right here would then mean equinox, equal above, equal below, and that would be autumn equinox or fall equinox. As we continue around, goes through this way. Notice I'm not moving where the axis is at. And now if you look at where the United States is at, the United States is approximately higher up. And then the sun's direct rays are now below the equator. And so this would represent winter solstice. It's where the sun goes down the lowest point in the southern hemisphere. As we continue to go around and around and around again, oops, it keeps rotating and keeps rotating. Then we come over here to spring equinox. Again, the equator is right where the direct sunlight is at. So again, it starts to get warmer as the direct sunlight gets up a little higher. As it continues around and around again, it's getting back to where summer is at. And again, you'll notice over the top of the Tropic of Cancer. Tropic of Capricorn is down here, Tropic of Cancer. Now, here's to add another thing of confusion for you. So if this represents the moon, as this is going around, I'm not going to have it exactly perfect, as this rotates, the moon rotates or revolves around with the earth. And it actually goes at the exact same speed. So you'll notice that the same side of the moon is always seen. So it takes 27.3 days for the moon to go around. And you'll notice it does not rotate like this, like the earth goes around the sun, but rather it stays just like this. It makes one complete revolution every 27.3 days, and also one complete rotation every 27.3 days. So in other words, a day, it takes 27.3 spins of the earth in order for this to go around once, just like that. Now, as we continue to look at this over here on this map, you can see actually, Mrs. Wilson, if you want to turn that back on for me, right here is approximately where the direct sunlight would be at right now at the very beginning of August. What we see is at one point on June 21st, June 22nd was when it was summer solstice. That's where it got up to the highest point on the Tropic of Cancer. And then throughout the summer, it continues to go back down. And then right about in here, September 21st, September 22nd, around in that ballpark, will be fall equinox or autumn equinox. As winter continues to go around, it'll come down here to the Tropic of Capricorn, and then that will be winter solstice, December 21st, December 22nd. Goes back up, and the process continues to repeat itself. Now, one final thing that I want to fill in with you about this would be with the eclipses. We got to see a great eclipse just a few years ago, and it was a pretty awesome thing. What this would represent would be right here. If the moon is right here, that would represent solar or sun, moon, earth. And this is what you would call a solar eclipse. Most of the time, the earth is not in direct alignment with the sun and the moon. Most of the time, the moon is above, it's below, but once every great many years, the moon passes exactly in front of the sun, and it forms a little shadow. Now, it's not going to be very easy to see on the video here, but it's just a tiny little spot, and it only lasts for a few minutes in almost every single place. More commonly speaking, though, is we have something called a lunar eclipse, to where it goes sun, earth, moon. And the reason why this is more common, look at the bigger shadow that the earth will cast upon the moon. And so you can see the bigger shadow up here on the whiteboard versus what the shadow was of this ball. And so again, it will then pass in front of it, and you will see this at nighttime only during a full moon, and it only happens once every maybe year or so approximately. It can happen more, it can happen a little less, it just depends. But then again, the earth will pass in between, and it will not be able to see the moon, and it will happen for over a period of maybe an hour or two versus only a few minutes with a solar eclipse. There's a lot of other things I would love to show you, and I can't wait to see you all back in person again when school starts back up. But thank you for this time, and hopefully that you had a good day. I was looking down at the flashlight instead of the phone. So, all right, good deal.